At the end of the topic, you will be able to recognize the fundamental trigonometric identities, prove the trigonometric identities, solve problems using trigonometric identities. What is an identity? An identity is an equation which is true for every value of the variables. For example, the equation a squared minus b squared is equal to a plus b into a minus b is an algebraic identity since it holds true for any real value of a and b. Similarly, the trigonometric identities are equations involving trigonometric ratios that are true for all values of the occurring variables. These identities are useful whenever expressions involving trigonometric ratios need to be simplified. Fundamental trigonometric identities. The following three fundamental trigonometric identities are also known as Pythagorean identities. Identity 1. Sin squared theta plus cos squared theta is equal to 1. Identity 2. Secant squared theta minus tan squared theta is equal to 1. Identity 3. Cosecant squared theta minus cot squared theta is equal to 1. Let us prove the identity sin squared theta plus cos squared theta is equal to 1. Let OMP be a right-angled triangle. Right-angled at M and angle MOP is equal to theta. By Pythagoras theorem, OP squared is equal to OM squared plus PM squared. Sin theta is equal to PM by OP. Cos theta is equal to OM by OP. Now, use the ratios of sin theta and cos theta and substitute these values in sin squared theta plus cos squared theta. On simplifying, we get OP squared by OP squared, which is equal to 1. Therefore, sin squared theta plus cos squared theta is equal to 1. This is true for all values of theta and hence an identity. Let us prove the identity secant squared theta minus tan squared theta is equal to 1. Let OMP be a right-angled triangle. Right-angled at M and angle MOP is equal to theta. By Pythagoras theorem, OP squared is equal to OM squared plus PM squared, which implies OM squared is equal to OP squared minus PM squared. Tan theta is equal to PM by OM. Secant theta is equal to OP by OM. Now use the ratios of secant theta and tan theta and substitute these values in secant squared theta minus tan squared theta. On simplifying, we get OM squared by OM squared, which is equal to 1. Therefore, secant squared theta minus tan squared theta is equal to 1. This is true for all values of theta and hence an identity. Let us prove the identity cosecant squared theta minus cot squared theta is equal to 1. Let OMP be a right-angled triangle. Right-angled at M and angle MOP is equal to theta. By Pythagoras theorem, OP squared is equal to OM squared plus PM squared, which implies PM squared is equal to OP squared minus OM squared. Cosecant theta is equal to OP by PM. Cot theta is equal to OM by PM. Now use the ratios of cosecant theta and cot theta and substitute these values in cosecant squared theta minus cot squared theta. On simplifying, we get pm squared by pm squared, which is equal to 1. Therefore, cosecant squared theta minus cot squared theta is equal to 1. This is true for all values of theta and hence an identity. Corollary of Pythagorean identities. The following are the useful results deduced from the three Pythagorean identities. Corollary 1. Sin squared theta plus cos squared theta is equal to 1. Sin squared theta is equal to 1 minus cos squared theta. Cos squared theta is equal to 1 minus sin squared theta. Corollary 2. Secant squared theta minus tan squared theta is equal to 1. Secant squared theta is equal to 1 plus tan squared theta. Tan squared theta is equal to secant squared theta minus 1. Corollary 3. Cosecant squared theta minus cot squared theta is equal to 1. Cosecant squared theta is equal to 1 plus cot squared theta. Cot squared theta is equal to cosecant squared theta minus 1. Let us look at an example. Prove the identity sin power of 4 theta minus cos power of 4 theta by sin squared theta minus cos squared theta is equal to 1. Click on the solution button to view the solution. Now, look at another example to understand the identities better. Prove the identity 1 plus tan squared theta into cot theta by cosecant squared theta is equal to tan theta. Click on the solution button to view the solution. In this topic, you have learned Pythagorean identities. Identity 1. Sin squared theta plus cos squared theta is equal to 1. Identity 2. Secant squared theta minus tan squared theta is equal to 1. Identity 3. Cosecant squared theta minus cot squared theta is equal to 1. These identities are true for all the values of theta.
Applications of trigonometry. Trigonometric ratios are applied in the problems related to heights and distances. These application problems will enable us to measure the distance between different objects. For example, the width of a river, the height of a building, distance between two ships, distance between a lighthouse and a ship. Line of sight. The eye or the point from which an object is viewed is the point of observation. From the point of observation, the object is viewed only at a particular position. This position can be to the top of the object or at the bottom or anywhere else in the body of that object. An imaginary line segment joining the observer's eye and to the point of observation is known as the line of sight or line of vision. Angle of elevation. If the object is above the horizontal level of the eyes, we have to turn our head upwards to view the object. Thus, the angle between the horizontal line drawn through the observer's eye and the line of sight is called the angle of elevation. Angle of depression. If the object is below the horizontal level of the eyes, we have to bend our head downwards to view the object. Thus, the angle between the horizontal line drawn through the observer's eye and line of sight is called the angle of depression. Since alternate interior angles are equal between the two parallels, angle of elevation is equal to angle of depression.
The height of a lighthouse is 200√3 meters. The light from the lighthouse falls on a boat at an angle of 60 degrees. Find the distance between the lighthouse and the boat.
Join the top of the lighthouse to the boat by a straight line, and also join the foot of the lighthouse with the ship by a straight line. And thus the triangle ABC is formed, with AB being the height of the lighthouse and angle BCA equal to 60 degrees. The height AB is equal to 200√3 meters. Now let us represent the given situation diagrammatically as shown. Now assume the distance between the bottom of the lighthouse and the boat, that is BC, as y. In triangle ABC, tan 60 degrees is equal to opposite side divided by adjacent side, that is 200√3 divided by y. Substituting the value of tan 60 degrees as √3 and further simplification, we get the value of y as 200. Thus we get the distance between the lighthouse and the boat as 200 meters.
An aeroplane flying horizontally 750 meters above the ground is observed at an angle of elevation of 60 degrees. If after 5 seconds the elevation is observed to be at 30 degrees, find the speed of the aeroplane.
An aeroplane flying horizontally, which is 750 meters above the ground, is observed at an angle of elevation of 60 degrees. If after 5 seconds the elevation is observed to be 30 degrees, let us find the speed of the aeroplane. Let C be the position of the observer. The distance actually traveled by the aeroplane is equal to AB. Since AB is equal to DE, now let's find the distance DE. In triangle BCE, cot 30 is CE by BE, or square root of 3 is equal to CE by 750, or CE is equal to 750 into square root of 3. Name this equation as 1. Also, in triangle ADC, cot 60 degrees is equal to CD by AD, or 1 by square root of 3 is equal to CD by 750. Thus, on simplification, we get CD is equal to 250 into square root of 3. Name this as equation 2. Therefore, from equation 1 and 2, we get DE is equal to CE minus CD, which is equal to 750 into square root of 3 minus 250 into square root of 3, which is also equal to 500 into square root of 3. Now, speed is equal to distance by time is equal to 500 into square root of 3 by 5, which is also equal to 100 into square root of 3, which is also equal to 173.2 meters per second. Thus, on converting the unit of speed from meter per second to kilometer per hour, we get 173.2 into 18 by 5, which is equal to 623.52 kilometers per hour.
Example 1. A circus artist is climbing from the ground along a rope stretched from the top of vertical pole and tied at the ground. The height of the pole is 18 meters and the angle made by the rope with the ground level is 37 degrees. Calculate the distance covered by the artist in climbing to the top of the pole. Click on the solution button to view the solution. Example 2. An aeroplane, when 6,000 meters high, passes vertically above another airplane at an instant where the angles of elevation of the two aeroplanes from the same points on the ground are 60 degrees and 45 degrees respectively. Find the vertical distance between the two planes. Click on the Solution button to view the solution. Example 3. An aeroplane pilot, while flying over a river of width 200 meters, observes the angles of depression of opposite points on the two banks of the river to be 45 degrees and 60 degrees. Find the height at which the plane is flying. Click on the Solution button to view the solution. Example 4. The angles of elevation of the top of a tower of height 120 meters from the top and bottom of a house is 45 degrees and 60 degrees respectively. Find the height of the tower and the distance between the tower and the building. Click on the Solution button to view the solution.